This project of the Jenkins pipeline. Today we are going to be building a full-fledged Jenkins pipeline. What we are going to be doing today is actually industry standard. What we are going to be doing today is actually what is being done in the industry, in the companies. What when you are in the company as a DevOps engineer and your role is to build pipelines in Jenkins, what we are going to do today is exactly what you are going to be doing in your company. All right, so consider a situation where you are in the company and there are DevOps engineers, there are programmers. You know about programmers, you know about DevOps engineers, you know about every other specialty. There are operations engineers, there are system reliable engineers, and all the like. So you are a DevOps engineer and then you just get a ticket. A ticket is just like an assignment telling you that there's a new project that is coming. There's an application that needs to be built. A brand new application needs to be built, and in that brand new application they are expecting that you should create a pipeline for that application. That's a ticket. A ticket just comes to you that please create a pipeline for a new product that we are going to be onboarding very, very soon. Okay, that is what the ticket says. Now, on your own part now, in order to create that pipeline, what are you going to be doing? Let us see. Okay, this is what we are going to consider. We are going to consider you sitting here on top of your laptop, right? You are here on top of your laptop. Now you have to create a GitHub repository. First of all, you have to create a GitHub repository, and then you have to create an initial code. You have to tell a developer, because you are working hand in glove with the developers. So there is a new project that has been onboarded, and that project is going to be built in Java. Okay, so all the initial processes that we did in Maven, the lead developer of that project is going to do those initial processes, and when he does those initial processes, he is going to give you a code that is capable to deploy at least the basics of that application. I mean, a basic like a hello world. That code is able to print hello world on the browser, right? It is on top of that code that you are going to be building now the new application. So he will give some sort of a base foundation to you. Okay, he will develop the pom.xml file. He will develop all the files that Maven's the initial job that Maven's develops, as we did it when we were actually introducing our DevOps course. All those files that Maven's always develop, they are going to be developed by the lead programmer of the project. Then when he does that, he is going to give the project to you. So a folder will be handed to you. A folder will be handed to you that contains code. Okay, this folder is being handed to you, and then what are you going to do? You are going to take this folder, you put into this folder is the code, the basic code of the pipeline of the new project that you are going to be building. So as this program code is handed to you, you are going to have it inside your computer, inside your laptop. Okay, now as you have it inside your laptop, you are going to create a Git repository of that project in your company's GitHub account. You are going to create a Git repository in that in the GitHub, and then you are going to clone that repository. When you create a Git repository, the first thing after you create that Git repository is you are going to clone the Git repository. That means the first thing is creating a Git repository in your GitHub account. Then you clone the Git repository back to your computer. Okay, you first of all create a GitHub repository. Then after you clone the GitHub repository into your computer. When you create the GitHub repository into your computer, what will happen? A file will be created in your computer. When you create that GitHub repository, a folder, not a file, a folder will be created inside your computer. That folder is coming from this GitHub repository that you have just created. Now, when that folder is created inside your computer, you then copy the code that this person gave you, right? You copy the code, whatever code was inside here, please. Whatever code was inside this folder that this person gave you, whatever code was there, you then copy the code into that folder that you have, that empty folder that you have just cloned from the GitHub repository. When you copy that code inside here, now all the changes of that of the code are going to be done inside in your machine inside this particular folder. This is the same thing that all the engineers that are working in the project, they are going to do. Every engineer is going to clone the code into his own machine. Each and every engineer clones the code into his own machine. So your first job is create this repository so that engineers can clone the codes, the repository into their machines and start working. That's the meaning of DevOps. Everybody starts working at the same time. So if the project comes today or Monday, the first thing you should just do is create the repository as fast as possible so that people start cloning the repository and start working on their various parts. Okay. Now the second thing you are going to do is, as the repository has been cloned, you are going to start building the pipeline. What is the pipeline that you are going to build? Now, each time a code is being committed, that means each time an engineer finishes and writes a commit. You know what is a commit? When an engineer, a programmer finishes and writes a commit, he will push the code back into the repository. A new code will be added. So the code will begin and it will be a very small code base, a very small one. And then after some time, it will add. After some time, it will add. So as they keep pushing, the code will be adding. Okay? As the code is adding, the pipeline is being built all together. So as you are pushing the code here, what will happen? The first code will get downloaded. You prepare now a Jenkins pipeline. What is that Jenkins pipeline going to do? In that pipeline, this code will be downloaded to the first Jenkins server. The code will be downloaded in the first Jenkins server. And what will happen in this Jenkins server? When this code will be downloaded, a series of things will occur in this server. The first thing that will occur is there will be integration testing. Remember, why is there integration testing? Why is there integration testing? There is integration testing. Yes, Ryan.
Integration testing, I think it should test how the different parts of the code interact as one.
Thank you very much. That is just it. Remember that there are so many developers working on this particular code. That is the truth, right? There are so many developers working on this code. So each and every developer will be sending his own code. And the first thing that you should want to do is make sure that the code that has been sent from all the developers do have a good integration. They integrate together and they can communicate together. So that's the very first test that you are going to do. All right. Now the second test that you are going to run in this very server again is going to be the unit test. The unit test. What does the unit test do? Yes, Roberto.
A unit test is to test each and every individual component separately.
Exactly. That is to test the building blocks of the code. If the code was meant to say that 1 plus 1 equals 2, you have to test and see whether is the code actually saying that 1 plus 1 is equal to. If a unit of the code was to test 1 plus 1 equal 2, this will be tested at the level of the unit test. Okay, now when these two tests are successful, now you can now go to code build. You can now go to code build. Now in code build, now the code is being transferred from the source code. Remember that it is coming from here as a source code. It is being transferred from here now from a source code into what? Into something we call a jar file or a war file or whatever file that you desire, right? The code will be transformed from a jar file or a war file, from a normal code into either a jar file or a war file. That means an artifact will be generated. Okay, an artifact will be generated at this level. When that artifact is generated, now what are we going to do with the code? We are going to send the code to the second server. What is the second server? The second server is going to contain, this one is the Jenkins server. We are going to have the Jenkins server, and then the second server is going to be the Sonarqube server. Now the code is going to leave from the Jenkins server, and then it will migrate to the Sonarqube server. In the Sonarqube server, what is going to happen there? There are still going to be a lot of the code has been built. Okay, it is now a jar file or a war file. So inside this server, what is going to happen there? The first thing that we are going to have here will be unit test analysis. Not unit test, static test analysis. That means you are going to test the program, the application statically. It is not running. You are testing the application statically. The application is there, but you are going to test it as it is, wholly like that. Okay, that's the first test that you are going to do there. And then the second one that you are going to run in Sonarqube is what we call quality gate analysis. Now here is where all the bug testing is being done. Okay, here it is where the code tests for bug smells. It tests for long codes, unnecessary long codings, where if you are a programmer, the person that does the configuration of Sonarqube is a very high level programmer who knows how to write a long code in a very short way. So if a long code is written unnecessarily, the quality test gate analysis will say that this code is unnecessarily long. There is a shorter way to write the code. Okay, and then they put some various tough standards by which, if the code does not meet that standard, it will fail in this test. It will fail at this level. So the quality gate analysis test is done inside Sonarqube. Okay, now after this quality gate analysis is done in Sonarqube, what happened? The code is finished from Sonarqube. It moves now to what? You can now keep the artifact. There are two things you should do. The first thing is you keep the artifact directly in an artifactory. What is an artifactory? An artifactory is a warehouse of where artifacts are being kept, right? So if they ask you in an interview, which artifactory do you people use? You say you guys have been using Nexus as your artifactory. So we are going to get the Nexus server here. Nexus server, which is our artifactory. When we talk about artifactory, we talk about a place where artifacts are being kept. So this code has been built, and then it is either going to be sent as an artifact to be kept at the level of the artifactory, or we can directly dockerize this code. Okay, from here it is possible that we can just dockerize the code. From here we can dockerize the artifact and write a Docker file. You get it? We write a Docker file. Write a Docker file where the code, the artifact, instead of being kept here as an artifact, because it can be, we can keep the artifact here. Instead of being kept here as an artifact, we dockerize it, and we have it as a container, and as a container we send it now to Docker hub. Docker hub is at the level of the cloud. Okay, we send it to Docker hub. Now the code, after being dockerized, we can now subsequently send it to Docker hub. Okay, when we send it to Docker hub, the code is now present in the image. When we dockerize, because after we are dockerizing here, we change the artifact into an image, a Docker image. All right, so the Docker image is being sent to Docker hub. Okay, at this level the code is now an image. Okay, a Docker image. All right, now from the cloud, now you can pull the image from the cloud and run it as a container. It is possible for you to pull the image from the cloud and run it now as a container, and then you deploy to a different server. Okay, so this is going to be now the server where the code is going to be running as a test. Okay, you can deploy the code directly as an image or a container here, or you can deploy the code directly into a server here, that is a normal EC2 server, not a containerized server, not a container, not a microservice, a normal server that we know. You can deploy the code there. But the industry standard where everybody is moving towards Docker is that the code is dockerized through a Docker file. So we are going to write a Docker file along our pipeline, and then we are going to send the code to our Docker hub, and subsequently we'll pull the code from our Docker hub and we'll deploy the application into a server which is hosting Docker, and we will be able to access our application in this server. Okay, so this is what we are going to do, and this is the general pipeline structure that we are going to follow. Okay, so we are going to cut this project into two. As I said, we cannot finish the whole project at once because the video will be too long, and sometimes maybe it will really get heavy for your novice to go through. Okay, how many servers are we going to create at the start? So for this, our beginning, for our start, we are going to try to make sure that we create our GitHub repository. We do all the configurations that needs to be done at this level. We push the code and create our Jenkins server, we create our Sonarqube server, we create our Nexus server, we configure all of them. We build this pipeline where the code is sent to our GitHub, and then the pipeline is triggered from here, and then the build stages take place. All these integration, unit tests, code build, static test analysis, quality gate analysis, all of them take place, and then the code is finally pushed to Nexus. The artifact is pushed to Nexus. If we can attain at the level where the artifact is being pushed to Nexus here, I think we can stop there for today, and then maybe tomorrow we take over from dockerizing the artifact and pushing it to Docker hub, and then subsequently pulling it from Docker hub and deploying it into an EC2 server. Okay, this one is a normal not a Docker server. and an EC2 server, please. A Docker server. This server will have Docker installed in it. So we are going to deploy the artifact as a container. Okay. We can also deploy the artifact as a normal jar file, but we want to deploy it as a container. All right. That is our main goal here. That is to follow our main purpose of why we are here. So we are going to create. Yes, Roberto.
Yes, sir, please. Why is it that Kubernetes is not intervening yet?
Okay, we can continue the project with Kubernetes. Okay, now once the code has been deployed, once the code has been containerized as a Docker image, okay, we can either decide, instead of deploying it as a Docker file, we can either decide and just deploy it as a pod, not even a Docker file anymore. Okay, so if you wish, tomorrow we can decide, and instead of saying that we are deploying it in a Docker server, we deploy it as a Kubernetes pod. Once you already have an image, you can deploy as you want, right? If you already have an image here, you can either deploy as a normal Docker image, or you can deploy it as a Kubernetes pod. You already have it. Is it clear? The most difficult thing is to have an image. That is the most difficult thing. Once you already have an image, it is your decision whether you want to deploy now as a Kubernetes pod, or you want to deploy it in a normal Docker server. It is your decision now at that particular moment, right? So we are going to deploy it as a Docker server, and the same as a Kubernetes server, okay, for clarity.
Yes, sir, but is there not an advantage of using therefore Kubernetes over the Docker?
Of course, there is always an advantage. That is why we took a Kubernetes project, a different Kubernetes project. Okay, we took a real different Kubernetes project. Kubernetes projects always begin at the level of images. Okay, the images are already there in the repository, and then you are downloading the images from where they are, and then you are deploying them as pods. That is where Kubernetes projects begin. Okay, the first stage of the project is actually building the application and actually arriving at the level of transforming the application into an image. That's the difficult part. Kubernetes takes over when the application is already an image, which is of course very advantageous, or more advantageous than Docker Swarm, if we can put it. It is more advantageous than Docker Swarm. Is that clear?
Okay, yes, sir, it's clear.
All right. So we are going to be creating how many servers? We are going to be creating, for the first section, we are going to be creating 3 servers, right? The first server is having Jenkins. The second server is having Sonarqube. The third server is having Nexus. Does it go in line with our context of the dev environment, the prod or the QA environment, and the prod environment? Does it actually respect that concept? Yes, it does, because all this Jenkins server is a development environment. The Sonarqube server is the QA environment. That is where all the testing takes place, at the level of the Sonarqube server. Okay, that is where the testing, everything takes place, because that is where everything happens. That's the QA environment. When the testing is okay, the first deployment is deployed. Now listen to the language I'm using, please. When everything is okay here, the first deployment is deployed into the staging environment. Are you getting now the difference? Into a staging environment. There's a difference between a QA environment and a staging environment. What is the difference? So in your you should not go into an interview and you say your QA environment. They ask you what is happening in your QA environment. You cannot explain. In your QA environment, what is happening? Just like the name says, quality assurance. it is an environment where quality is being assured. Okay, the real quality is being assured there. So all those tests are being performed in the QA environment. What sort of testing? Static tests, quality gate tests. There are so many tests that occur. Okay, companies decide. Regression testing, companies decide whichever test is occurring there. And don't worry yourself, there are experts for writing test scripts. It is not the work of an engineer or a DevOps engineer to write test scripts. Okay, because I know some people, or I myself, I was so afraid because I did not understand what is testing and all the like. Testing is also another field on its own, which if you want to increase your own personal knowledge, you can decide to know how to write these test scripts. Okay, I will show you a test script and show you how it looks like. All right. So
are they paid more, sir?
No, actually, please, let me just say this as we continue, because all of us, we are interested in money, and money. As you are growing in your DevOps, as you keep practicing and keep understanding how this thing is functioning, try to move towards security. Okay, DevOps is presently one of the highest paying job, and I mean it is one, the need for DevOps engineers, especially microservice people who understand microservices like the Kubernetes, the Dockers, the Terraforms, and all the configurations. People who understand that are highly in need today. Now, at least some people have managed to break in and understand the concepts, and they are there. Now, some very high level companies are now moving an extra mile towards their security. Some companies do not want to use the cloud. Some companies want to work on private cloud, and they are so much orientated towards their security. Other companies want to use the cloud, but they want to be very assured that their security is up to standard and nothing can happen with their data. Okay, so they are now looking for who can give them that extra security. So DevOps is moving drastically to DevSecOps, and at the level of DevSecOps, I can tell you, in the whole world, I mean the world at large, if you can see up to 100 to 200 engineers that are strongly qualified with DevSecOps, then they are much. I mean the whole world. This is how that environment is much needed. Okay, when we finish DevOps, I will give you the whole program for DevSecOps, for SecOps actually, because you already know DevOps, and then I'll give you a whole program for SecOps. But what I want you to do is, first of all, you get a job in DevOps, and then from the job in DevOps, now you can get a training in DevSecOps. So move towards DevSecOps, not trying to quality in analysis is just a small branch in DevOps on its own. Okay.
Sir.
All right. Let's go start coding. As I said, it is going to be a very long project, so we will really need to cut it into two because we will stay here. We are going to create 3 servers. Now, there is one thing I would like to say here. The servers that we are going to be creating are going to be high level servers. So please, when you are practicing, make sure you delete. Roberto, have you started practicing?
Not really, sir. I'm still going through the Kubernetes videos, but I'm actually planning to start very soon.
Okay. Please, when you start practicing, make sure you delete your servers immediately you finish. Don't keep them that you are going to come before you finish. Delete them immediately when you finish. Okay. All right. Let's see what to do. We are creating the Jenkins server, the Sonarqube server, and the Nexus server. All right. Here is why I say you should create servers and delete them immediately, because in your servers you are not going to be creating but T2 micro servers. You are going to create larger servers. That means you are going for here, you are not going for T2. Okay, T2 cannot support this project. T2 is unable to support this project. The least configuration that can support this project is T2 medium, and T2 medium is not free, so it is paid per hour of use. So you should be very careful immediately after you finish. So you take your key pair, and then you choose your security group, and then they at least have at least 20 GB of hard drive. That is what can work. So we need to have 3 servers for this to work. Let's launch our servers. Okay, the first one is the Jenkins server. The second one should be the Sonarqube server. Sonarqube server, and the third one should be the Nexus server. Cool. So we have the Jenkins server, we have the Sonarqube server, we have the Nexus server. Fine. Now the first thing is we have to start configuration. Okay, we have to install Jenkins and everything that needs to be installed, Sonarqube and Nexus. We have to install all these things. So let's connect to the first server, our first server, which is our Jenkins server, and see how we install Jenkins. We all know how to connect. Okay. All right. Our connection into our Jenkins server is ready. Okay, the first thing is we do apt update, right? We always update the repositories. Good. Repositories get updated. We create our simple shell script. Let's create a shell script. We create a shell script and we call it jenkins.sh, and then we look for our Jenkins script. I think I gave you the scripts. I have a Jenkins script. Let's go through what this Jenkins script is actually doing for us. This Jenkins script is actually going to update our repository, which we have already done. It is going to install OpenJDK 11 in our server. It is going to install Git in our server, and it is also going to install Maven in our server. It is also going to install Docker in our server, right? After installing Docker, it is then going to install Jenkins in our server, right? And then after it installs Jenkins, it is going to start the Jenkins. That is what the script is going to do for us. So each command, the first command is updating the repository. The second command is installing OpenJDK. The third command is installing Git. This is installing Git, and this one is installing Maven. and this -y means auto accept. Wherever they ask yes or no, just accept yes. This one is installing Docker, and it is also auto accepting yes. Then this one is installed downloading. This one is actually downloading the Jenkins file from the Jenkins website. It is downloading the Jenkins file, and then this one is the one that is executing the Jenkins file. Okay. This is the processes that we are going to be running here. So we copy our script, and we paste, we save, other. Now we can see that we have a shell script which we can execute now. sh So there are a lot of things there that needs to be done, so you need to give it some time to perform all the duties there. I think Docker is being installed now. Jenkins is starting. Finally, it's done. So we copy our Jenkins token. Okay, copy our Jenkins token, and then we minimize our Jenkins file. Let's just keep our token here. All right, we are done for Jenkins. Let us see if we can have access to Jenkins right now. Is Jenkins already running? We know that Jenkins is available on port number what's the port number for Jenkins again?
I think it's 80.
Port number for Jenkins should be 8080. So we have our code, our password for Jenkins, which we kept here. And we are in. Okay, so we just go in for suggested plugins for rapidity at this level. Let it install all the plugins, but we have a series of 10 different plugins that we must install. I'll give you all the list of plugins that are going to be needed in this project, and the use of those plugins. When we arrive at the use of those plugins, I'll give you why, if you did not install those plugins, what you would have noticed as a failed job. Okay, so I'll be giving you a list of 10 plugins which you must install. So but let's begin by installing all the initial plugins in Jenkins. At this level, please make sure your internet is at highest capacity. You might reach at this level and your updates fail. because here there is real dragging of internet here. If it fails, don't think that you are doing something wrong. Maybe there's something wrong with your internet availability. So you need to reconfigure Jenkins. Let's just take admin and take the password again as admin. Keep everything simple, admin, and full name, we just write VTA, and then email, we take the VTA trainings email. It doesn't matter, please. Okay, they are telling us that Jenkins will be available in this. We already know. Okay, start Jenkins. All right, our Jenkins server is up and running. Next server to configure is here is our form. Our next server to configure is our Sonarqube server. Okay, let's go ahead and configure our Sonarqube server. Let's first of all go to our EC2 and move to our Sonarqube. We take the connection to our Sonarqube server. We open a second window. After we connect, the very first thing is that we should update. Okay, let's just go as a super user, and then we run apt update. Okay, update completed. All right, for Sonarqube, I have also a script prepared for you here. Where is my Sonarqube script? All right, okay, this is the script for Sonarqube. We are going to be running Sonarqube as a container. Okay, so we will install Docker inside the Sonarqube server, and then at the end we'll install Sonarqube. Okay, so here is what we are going to be installing. We are going to install move this one. We are going to be installing updating, installing Docker. All this is all about installing Docker and configuring it. Okay, and then after we must have installed Docker, we are going to now run this Docker command to install Sonarqube. This is just a command for a Docker command. Okay, I hope you understand. This is just a Docker command that says that after the script says that after we must have installed Docker, this is all about installing Docker, downloading the transport certificates in Docker, arranging a repository, updating them. This is all about, all these commands are all about installing Docker. Okay, and then when we come now down here, we are going to now, after Docker must have been installed, we are going to now run Docker run in detached mode, and we are going to give the name of the container as Sonarqube because we are running Sonarqube as a container. And we are going to do a port binding at port 9000 because that is where the container is going to be exposing, but naturally the container came at port 9092, so we are going to be bringing it back to port 9000. And then this is the place, the Docker repository that we are taking the image from. Okay, we are taking the image from this repository, so it's not an official image of Sonarqube. We are taking the image that is already prepared for our project. So we copy the whole script. It's a shell script, So this is what we call shell scripting. Okay, all about writing shell commands in Linux and everything. If you can rearrange all these things, then you know how to write the necessary shell commands to do most of these things, then you can do your shell scripting very well. Okay, so we come now to our Sonarqube. We create our shell script. Let's just call it sonar.sh. Then we paste, then we save and quit, then we run. Okay, Docker is being installed, and when Docker will finish installing, then Sonarqube will install itself. So here we are still pulling the images of Docker and updating the repositories. Now Sonarqube is getting pulled. And the installation is about to begin in detached mode. The installation is running now in detached mode, and it is completed. So we have successfully installed Sonarqube. Question: how do we access Sonarqube? Sonarqube is accessed, as we said, through port 9000. Okay, so we go back to our instance. We get our this is our Sonarqube server. We get our IP address, and we say Sonarqube is accessible in port 9000. Always make sure your security group grants you the opening of all these ports. Okay, without which you are not going to survive. Okay, when Sonarqube comes for the first time, you will need to log in. Okay, when Sonarqube comes for the first time, you will need to log in. So you click on login. The primary login is admin, and the password is admin. So when you do this, you will be logged in into your Sonarqube. So you are already available into your Sonarqube. I will show you how Sonarqube is being used. So we have finished the configuration of Sonarqube. The last configuration that we have to finish is that of Nexus, and that of Nexus is almost similar to that of Sonarqube. We are also going to install Docker, and then at the end we install Nexus. So let us look at the configuration file for Nexus. So this is the file for Nexus. At the beginning we install Docker, and then we run Nexus also as a Docker container, right? And we are going to be exposing Nexus in port 8081. Okay, so let us get connected to the Nexus server. After getting connected, the first thing is always to first thing is always to update. I'm unable to zoom. I don't know why. Okay, let us update. Very first thing to always do, apt update. So remember that we are configuring the Nexus server right now. So here we have to create a shell script. And in that shell script, let us see what we need to post there. This one is installing Sonarqube, so this one should be installing Nexus. This is the one for Nexus. I'm going to send to you all the scripts, please. I think you already have them even. So we're exposing Nexus at port 8081. So let us execute. I wrote it wrongly. We do it. There's a twist in Nexus on how to get the initial password for Nexus, and I think I'm going to show you how to get the initial password for Nexus because it is a bit complicated. So the Nexus is being pulled now. Installing in the background and done. Okay, now Nexus has been installed. Now we can access Nexus. They say Nexus is available at port 8081. So if we go to Nexus and we take the IP address and we go to port 8081, we should be certain that we should find Nexus there. Nexus is not yet up and running. Let's give it some time and hope it installed correctly. Let's grant it some patience. Now it is coming. So our Nexus server is on now, but signing into Nexus, if you come and you use admin and you also use admin, you will never succeed. Okay, you see password not match, right? And if you go to this site, nexus-data-admin password, you will not even see this site. Okay, you will not see this directory because we are using containers. So how to get to this directory? Unfortunately, I am unable to increase the size of now it accepts. Okay, how to get to the site where the password for Nexus is located? The password for Nexus is located in this path. Please look at the path very well. I'm going to cd. I'm first of all going to var. Okay, I'm going to lib. Let's go one by one. I'm going to var ls there. I'm moving to lib ls there. I'm going to docker. Should we have docker here? Here is docker. I'm moving to docker. Ls there. Then I'm moving to volumes. Ls there. Then I am moving to this long thing here. This is a repository like this, very long repository, very long name of a repository. I cd into that repository. Ls there. Then I cd into this data underscore data. Okay. And then I ls here. I will see now the admin dot password here. I copy the admin dot password. I open it. Now look at how I'm opening. I'm opening with the vi editor. So I'm opening the admin dot password. That's where the password for Nexus is located. Okay, it's a one-time password. You take it and then you put it in your Nexus. Now you are in. Okay, when you are in, you will be asked to configure Nexus. Next, you give a new password. You can still give your admin, and here you can still give your admin. Admin will still go. All right, now when you are asked, just enable anonymous access for simplicity, please. And now we have configured our Nexus server and we are in. So we have now our Jenkins server, we have our Sonarqube server, and we have our Nexus server. What is lacking here? We have this server, we have this server, we have this server. Now the only thing that is lacking is our Git repository. Our Git repository is not yet there. Our GitHub repository is not yet there. So let's go and create a repository for this pipeline. So we go to our GitHub. Let me log into GitHub. Okay, I am in my GitHub repository. I think this happened because I am automatically logged in into this other window here. Yeah, let me log out from here. I'm am I to log out even? Anyways, I don't need to log out for any moment. Okay, we are in GitHub. So you all have your GitHub accounts. I'm very sure everybody has their GitHub accounts. So when you come to GitHub account, you are going to create a repository. Let's consider that you are in the GitHub account of your company right now. Okay, you have your own login, so you are going to create a new repository in your GitHub account. Call it a name. Okay, DevOps project. DevOps project 1. Let's call it like that. DevOps project 1. Okay, let's describe it. Building and deploying in Docker and Kubernetes. Let's make the project public, and then we put add a readme. Projects always come with their readme. It's always good to create a readme, and then we create the repository. That's all about creating a repository. We have created our repository. Repository is created. Our repository is called DevOps project 1. Okay, our repository is created. Now when our repository is created, the next thing is we need to download our repository. Okay, we need to download from our repository. If we are to download from our repository, what are we going to do? We are going to clone. So we copy our repository URL from here. You come to where there is this code, you click it down, and then you copy your repository URL from here, and then you go to where you want the project to be in your computer. Where do you want the project to be in your computer? Me, I want the project to be in my computer among my projects. I have a folder here called projects. Yeah, so in that folder called projects, I would like to put the project under DevOps project, and I would like to clone it inside here. So I'll open git bash from here, and then I'll clone the project here. I'll paste now the URL. Now you see DevOps project 1 has been cloned. This is DevOps project 1. If you don't clone the project, you will face difficulties pushing. Okay, you have to just first of all create an empty repository and clone that empty repository. The repository will come only with a readme file and a .git file that it is already versioned. Okay, now remember that I said it is only when you have created this repository and clone it into your computer that you now take the code that was given to you by your head of programming, your head of the development team. The head of those who are coding is going to send you the pom.xml file, the readme files, all the various things that makes the foundation of the code. He is going to give you. You are going to now put into that new code, that new one that you have just created here, that new repository that you have just created here. You are going to put it inside, and then you are going to push it back into the main repository. Now every other developer will also do the same. They will clone the repository. Each and everyone clone the repository and start working on their own separate branches, where they will start pushing back the code into this main repository. Okay, so let us consider that this is a code that somebody has brought to you. Okay, this is our project. and the code that they send to us. Here is the code. Let's just take let me take from here. Okay, let's take, this is the code. The code is containing an src folder. The code is containing test folders and a pom.yami.xml file. This is the code that they send to you. So they have sent you this code. Actually, this is actually what will be sent to you, that okay, this is the foundation of what will be developed. So you take it and prepare everything that needs to be prepared there. So this is the code that has been sent to you here. So you copy the code and you paste here. So what have you copied and pasted? Let us go throughout what you have copied and pasted. You have copied the main source code. This is the source code. You understand the meaning of src. This is the source code. Okay, and in the source code, we have already talked about all these things in Maven when we were studying Maven. Okay, because they will always ask you a question. You say you have worked with Maven, what is the use of the pom.xml file? I believe you will be able to answer that question when it comes. And inside the source code, how many folders are there? I mean, you know, there are two, the test and the main folder. So in the main folder, that is where we have our main code. Okay, it's a Spring Boot application, and the Spring Boot application only prints a hello world. Okay, so all the developers will be creating their folders and committing it inside this main folder. All right, that is where all of them will be creating their files and creating their files and writing code and committing here inside this folder. They'll be committing, each and everyone will be committing inside this folder and pushing. Okay, so that is where the code is. So we already have the foundation base of the code that is inside there. All right, now this mvnw, these are test scripts that have been written by test engineers that we are going to use. We are going to open the test scripts for you to see how they look like. Okay, all right, now you have the code in your computer. All right, the code is inside your computer. How now will you, as a DevOps engineer, work on this code as it is inside your computer? Now we have the code inside here, everything is inside here. What are you going to do with this code that is inside here? It to be able to send it back here. There are two things that you need to do with the code. The first thing is that you are going to prepare a pipeline file. You are going to prepare a pipeline file and add to this code. There will be another file that you are going to prepare. It is a pipeline file. They will always ask it in the interview question. In the interview, what is the main file in Jenkins? It is called the Jenkins file. That is the file that carries the pipeline code. It is called the Jenkins file. Okay, so you are going to prepare that pipeline file and you add here. So how will you do that? Will you just create it here? Yes, of course you can create it here, but the best way to do it is creating it through Visual Studio. So how should we open this directory through Visual Studio? You can just go, you launch your Visual Studio. Let's just launch our Visual Studio. My computer is getting very slow. Okay, we launch our Visual Studio. I want to launch a new Visual Studio. This is not the one that we launched. Okay, this is our Visual Studio that we have just launched. It would be nice working with the Visual Studio because it gives you a good gives you a good foundation of environmental development. You see exactly where you are working, you see what you are working on, and you see everything. So how do you open that particular directory? I know where the directory is found in my computer, so I'm going to start searching for it. So I go to files. I'm going to start searching for the directory because I know where it is in my computer. I say open folder. I go to open folder. Okay, folders open in my computer, so I know that my file is found in data, learning, projects, and DevOps, and this is it. So I don't open this one again because that's the main folder that I brought. So I just click on this one, right, when it appears down here, and then I click on select folder. Okay, my files open in Visual Studio. All of them are now open in Visual Studio. They are there. So they will always ask if you trust your source. You say yeah, you trust your source. Okay, now these are your various files. This is what I said they were the test files. Okay, these are the test files of the project. This is how a test file looks like. The test scripts, this is how they look like. Okay, it's a script that has just been written, and when we are going to execute test, it is going to run this script and it is going to perform all the various necessary tests that needs to be performed. Okay, then we know about the pom.xml file. We all know what it does. We already did this in Maven. Okay, then here is a source code. We know what is inside the source code. And then this is a readme file. You know, a readme file is where you describe everything that you do inside your code. Okay, because somebody will obviously come and take over that project some years to come. You will not work in the company forever. So when you do a least change in the code, you write it under the readme that I changed the code from this to this. I changed this so that this can happen. Everything that is happening on the code should be written in the readme file, so that if somebody comes and sit and go through the readme file, he will understand how the processes of the code development actually took place. Whatever thing you change in the code should be highlighted in the readme file. So we are not much interested there because that will certainly be done by developers. Where we are interested is you are going to create another file here, and it is your Jenkins file. How do you create your Jenkins file? Just come to new. You come down to new file, right? The name of the file will come up here. You just write Jenkins file. Take care of what I'm writing. Jenkins file. One interview they asked me the Jenkins file, what format is the file? Is it a .txs file, or is it a .lms file, or is it a .this? There is no dot in Jenkins file. It is just Jenkins file. Another file also where there is no dot behind it is a Docker file. Okay, don't get let these people not frighten you. It is Jenkins file. You just write it like that, and you create your file. You can press your enter, and that is the file that gets created in that particular directory. Create. So the Jenkins file appears here. This is the file that we are going to be working on it. Okay, this is our main file that we are going to be working on it. But before we start working on it, the very first thing we need to do is we will have to create a job in Jenkins. We cannot just start working on a file like that. We don't yet know. So the first thing is we have to go to Jenkins and we create a job. Okay, let's go back to our Jenkins server. This is our Jenkins server. So before we create a job in Jenkins, the first thing I want us to do is let us install the plugins that matter. I told you that there are a series of almost 10 plugins that you need to install for this project. You know, Jenkins is a place where you install plugins for plugins to be able to do the jobs that you want. Okay, for different projects you can install different plugins. For other projects you install different plugins. So for this project we are going to install a series of 10 different plugins. Let us see the list of the plugins. I took down a list here where I kept for you. I prepared this project for almost close to 3 months. I've been preparing this project. All right, the first plugin is the build pipeline. The second plugin is the deploy to container. Third plugin is copy artifact. Fourth plugin is Sonarqube scanner for Jenkins. Fifth plugin is all these plugins, you just make sure you deploy them one after the other. So let us search for the plugins. How do you install the plugins? Come to manage Jenkins. We already did this when we were doing deploying to Tomcat. Come to manage Jenkins and then you come to manage plugins. In manage plugins, you are going to go to available plugins. Let's start one by each. The first plugin is build pipeline. So let us go and search for build pipeline. This is a plugin, and then you always install without restart. Okay, you install it, you wait for it to get successful. It gets successful. The second plugin is deploy to container. So you go to available, you type in deploy to container. Here is it. Deploy to container will help us to move the application to Tomcat. If we want to deploy to Tomcat, that is what this plugin is going to do. It will help us move the application from Jenkins to Tomcat. That is what deploy to container does. Now we come again to available. The next plugin is what? Copy artifact. Okay, this one is going to help us to copy the artifact from one server to another server. Okay, available, copy artifact. Here it is. Copying the artifact from one server to another server gets deployed. Then the next plugin is the various Sonarqube attribute plugin. So we are going to install nearly all of them at the same time. Sonarqube scanner, Sonarqube generic coverage, Sonarqube plugin, Sonarqube plugin, and Nexus artifact. So let's see. We'll just write Sonarqube and nearly all of these will come out. So let's go to our Jenkins, available. We'll write Sonarqube. You'll discover that nearly all those plugins are there. So this is the first one. Sonar scanner is there. Sonar quality gate is there. Quality gate analysis is there. We have Sonarqube is there, and Sonar generic coverage is there. How many have we selected? We have selected 2, 4, 5, and here are the 5. Sonar scanner, Sonar generic, Sonar Gerrit, Sonar quality gate, and quality gate plugin. These are the 5 that we have selected and we have installed. Okay, all right, let us execute them. So after installing all of them, actually what they will do is they will help in the movement of the code from Jenkins to Sonarqube, and all those tests that we are going to be performing in Sonarqube. Without the presence of these plugins, those tests are going to be failing. Your pipeline is going to be failing. Okay, the next thing now is Nexus artifact uploader, pipeline utility step, and SSH agent. So let's start with Nexus artifact uploader. Go to available, we take Nexus artifact uploader, and then we go to the next one, which is pipeline utility steps, available, pipeline utility steps. Is pipeline utility steps already there? And then from there we go to the last plugin, which is SSH agent. This one will help us at the tail end of the project. SSH agent. Okay, we have installed all the necessary plugins that needs to be installed in Jenkins. So the next thing that we need to do now is to build the job in Jenkins. Okay, we need to build now a job in Jenkins. So let us go now back to Jenkins, and then new item. Let us build a job. The job that we are going to build is DevOps. Let's just call it DevOps 100. All right, and then it is now a pipeline. This is the first time we are building a pipeline job, right? It is now a pipeline. The jobs occur on their own. Okay, very good. The Indian says jolly good. All right. Our job is ready. Our pipeline is ready to be built. So what should we do in our pipeline? Remember our demonstration. The first thing is code should be able to leave from here to here. But before code leaves from here to here, it must first of all leave from here to here. Right, it must first of all leave from this place to this place. So how will the code leave from this place to this place? Let us open our VS editor. We write our pipeline. The first thing that you write is pipeline, and then you open your braces, and then you say agent. They will always ask you that what is an agent in Jenkins. An agent is like the computer that is going to be executing this job, and Jenkins can use the built-in computer, that is the computer where it is installed inside, or it can use a slave computer, that is another computer that is attached to it. So either it is using its inbuilt computer or it is using a slave computer. Whatever computer it is using, that's why we just say agent any. All right, if we wanted that it should use a specific computer, we will say agent this particular slave. All right, we'll point it to that particular slave, because sometimes you can be running 3 jobs and one job is running in one agent. So you can say agent this IP or this particular computer. Okay, so for this one we just say any agent that is available can run the work. Okay, the next thing that we write is stages. Okay, we open our braces. After stages, the next thing we write is stage. We open our braces. After stage, the next thing that we write is okay, in stages we will definitely write the stage here, and the stage here should be that's how you write the stage. The very first stage is continuous download. The very first stage is continuous download. So when you write the continuous download, you step down and write steps. Okay, now inside your steps you are going to write the script for the continuous download. Okay, so in the continuous download you are going to write a script, and then you are going to copy your GitHub URL, and then you are going to paste there. So I've also prepared a series of steps for you that you are going to follow. This is a continuous download script. You run this script and then you follow it with your GitHub URL. So I'm copying from here to here, continuous download. Then I copy now my URL. Okay, the URL of my job itself. So when I go to my GitHub account, I see this URL is there. I copy it, I come here, then I paste it here. Okay, I think we are good with that. When this is done, I can now save. I press Ctrl S to save, or you can still come and press File and press Save. Okay, save all. Now I have to open the terminal where I'm going to be working. So I come to these three dots, click the three dots, come down to terminal, and then open new terminal. Okay, when I open my new terminal here, remember your Git classes very well. We are working with version control and a source code management system. Okay, Git is a version control and a source code management system. So whatever thing that you do, you must run git add, because if you run git status now, you will see everything here is red. Let's run git status. You see they are all green now because I've passed them to staging directory. So git add, pass them to staging directory. Git commit, remember your commands, -m, you write your commit. This is just our first push. All right, now I don't know whether it will prompt me, but for the first push to your GitHub, it will ask you for authentication. So let's see. If it doesn't ask me for authentication, just know that in your case it might ask you for authentication. Git push -u origin main. I'm just pushing to the main branch, but in company policy, you are not going to be pushing directly to the main branch. You are first of all going to be pushing to, might be a development branch, then they are going to be taking that development branch before they are merging it to the main branch before the code is running in real time. So you will not be pushing, you don't push code directly to the branch that is running in the pipeline. Okay, this is just for our project sake. So git push -u origin main. I'm expecting that it should ask me for authentication. Okay, it has not asked, but in your case it will ask you for an authentication for your first time that you are going to do. And when it asks you for an authentication, you will need to either authenticate by a token, or you authenticate by the web browser by writing your username and your password. But the best way to authenticate is using a token. That is what you are going to be doing in the industry, because you are going to be creating a token meant for DevOps, for developers. So in order to create that token, I think I have showed you guys how to create a token. This is your GitHub account. How do you create a token? You come down to settings, then you go down to developer. There's something like developer settings, if I can remember very well. Let me first go to my code. Good. Then I come down now to this setting here. When you come down to this setting here, you come down and you see something like developer settings. Then you come down to personal access tokens, take classic tokens, and then you come here and you say generate a token, and then you say generate classic token, and then you see they'll ask me that I want to generate a token. For my security sake, I should put my password. Okay, I put my password and I confirm. So they're asking me, give the name of your token. For how long will that token remain? What is this token capable of doing? So you are going to, if you are giving a token to developers, you should not give a token to developers in such a way that the developers can enter your GitHub account and change things. No, the person that owns the GitHub account is the DevOps engineer, not developers. Developers are just there to be pushing code to the GitHub account. Okay, so you are going to be restricting the code here according to the accesses that your company decides. Okay, but for simplicity for our working, the token I'm using, I have clicked all these things. When you click this one, all these ones are selected. You click this one, all of them are selected. Okay, so if I click all these things and I come at the end of the day and I say generate token, a token will be generated. Okay, and when that token is generated, you can now use the token to log in with it. Okay, so let's at least for that part, I've already generated my own token. At least I've shown you how to generate your own token. If you are trying and it is difficult, you get to us, let us show you how to generate a token. All right, we can show you live. So in my own case, my code has been uploaded. So if I go now to my repository, if I come now to my repository, I am able to see that code is available. Okay, so let me not generate this token. I'm going back to my GitHub account. Okay, the repository was pipeline. No, I think it was show more repositories. That's how I have so many repositories. DevOps project, was it DevOps project 1? I definitely fucking have repositories. Okay, DevOps project 1. I think that is the repository. Yeah, just 5 minutes ago. This is the code that has been pushed into our repositories just 5 minutes ago. All right, so our code now is pushed into our repository. Now as the code is pushed into our repository, we have also written a code that the code that has been pushed to our repository, when we execute our pipeline, this command says that code should be downloaded into Jenkins. So let us go in and execute it in our Jenkins. We are going now to Jenkins. Now we are going to our job. When we come to our job, we will see build now. Okay, we want to build the job right now. So let us start our work. It might run, it might fail, we don't know. For the best thing, it is failing. Our job has failed, so that's good. We start the hard work of doing the job, which is debugging. When the job fails, what is happening? You open the code and you start checking what have you done wrong. Okay, because 100% your code will always be failing. 100%, I guarantee you. So started by user, no file definition cannot run the job. Okay, why has this happened? Because we have not configured Jenkins to actually take the job from GitHub. So how should we configure Jenkins to take the job from GitHub? Let us see what we need to do. In order to configure Jenkins to take the job from GitHub, let us come to our pipeline syntax. Let us go to configure, and then we say, okay, the first thing we want is we want the job to come from a source code management system. And what source code management system is that? It is Git. All right, they say, okay, it is Git like that. It is coming from which repository? You say that we go back to the repository. It is coming from this repository here. And credentials, no, we don't have any credentials for that repository. We made it public. And which is the branch where the job will be running from. Remember, we are running on the main branch. And what is the file that is going to be running that job? It is the Jenkins file. We are good to go. We apply and then we save. Let us try running the job now again and see whether it is going to download the code. Build. Now our job is running. See, the second one is running. It fails again. So let us see why it fails. Open. Okay, this one gives us line 10. It says that what? Git branch main URL GitHub. There's a problem with our GitHub branch. Let us see what the problem is. Let us see what the problem is in our GitHub branch. Okay, I think sorry for this. And for this, we have to put this branch in quotes. This one like this have to be in quotes. This one has to be in quotes. Okay, we try again. Git add. Remember that any change that you do, git commit. Any change that you do, you must do this. Fixed URL, and then git, you must also push -u origin main. When you do anything, you have to commit it. So let's try again one more time, and we run the job. You see, as the job is failing, you are seeing where what is being filled in the job, and you can debug as the job is filling. Okay, so let us see if we can run our job now. Build. The job is running for the third time. The job has run successfully. Now you see the job running successfully and shows you now a good user interface here. The job says declarative checkout, continuous download, succeed. Now we have one green tick here. I say when you have green ticks in your pipeline, it is more than an energy relieving and proton giving mechanism for you to be having green ticks. These red ticks like this can give you depression. Okay, our continuous download has gone successfully. So we said after we download, remember we said after we do continuous download, we are going to do integration testing, right? So the second thing now is, how do we write the code for integration testing? We go to our command line, our code line. We come down under this green or blue button. We step down. We write stage, brackets open, latest commas open. Now it is integration testing. Now when we write integration testing, step down the steps for the integration testing, and then now we write the code for integration testing, which I said I prepared it already for you. The integration test, you just run sh, that is the command that we have made there. They will run here like this. You paste it here, you save, and then you come here, you commit. Then just write integration. Then you push. The code is being pushed. We go back now to our pipeline and we run the code again, build now, and then we pray and hope that things work very well. Under normal circumstances, a third integration testing should come out here. It is already there and it should come out blue. We pray that it should remain blue. So it is running, the code is running integration testing on Sonarqube. Maven is running integration testing on the code and it has successfully gone past and it is good. Our integration test has run successfully. Now we go back to the third stage, and which is we write stage, brackets, test commands. The next stage is what? Unit testing. Now in unit testing, we go down to steps, we go down to script. No, we look for our script for unit testing. This is our script. Verify. actually I've made an error, please. Now this script is running, but integration testing verify, the command verify runs but integration testing, and the command mvn test runs unit testing. Okay, there is, I have a different here. Verify runs yeah, okay, no, it's okay. So verify runs yeah, verify runs integration test. So we should have first of all run integration testing before we run unit test. So we have written a different thing and we are writing a different thing, because we have written integration testing, meanwhile we are running unit testing. Okay, so the first thing we should have done is run unit test. What am I saying? Yeah, here we should actually run integration testing, and the integration testing that we need to run, this is the code for integration testing, so not this other one. So this one is the wrong code for integration testing. That's the right code for integration testing. And then for unit testing, this is the right code for unit testing. So unit testing is supposed to come before integration testing, please. But it would not matter. Our code, if our code is right, our pipeline will still run. So git add git commit m. Here now we are running unit test. And git push -u origin main. Okay, here now our code has been pushed. Let us build. We should see unit testing occur or arrive here, and pray it succeeds. Okay, our unit test is there. It succeeds. Okay, let us build the code now. After these two tests, the next thing now is we build the code. Okay, so we run now the next stage, which is stage, and the stage is continuous build, and the script is this is the script for continuous build. Mvn clean install. Now I save. I run my git add git commit u m, then I write my build. Git push hyphen origin main, and the code gets pushed, and I come here and I run my job. Okay, let's hope we see a build there. Okay, we have a continuous build there. Will it succeed? It does succeed. All right, please, we are going close to 2 hours, and as I said, I don't like our classes that are long. We are at continuous build. Don't we think we should continue tomorrow? Let us end the class here for today, and then we'll continue the session tomorrow, and
Okay,
make sure that we can, at least from here, it is almost the same thing now. The difficulty was setting up the infrastructure, and insofar as the infrastructure is already set, I think we can just continue from here tomorrow, and we go ahead. So we continue tomorrow. Everybody, good night to everyone.